Welcome to Mathematics. Today we'll be solving the Pearson Edexcel IAL January 2023 paper of P3. The first question is about functions. Now we're given this function over here, 9 minus x square, and I have to write down the range of this function in the first question. So if I want to sketch this graph, this is 9 minus x square. So this will have a turning point at 9, 0. So this is 9. This includes 0. So the function is to the right. So this part of the function is not over here. Only the function to the right of it is considered. And the maximum point over here is at 9, and it can go below that. So the range of f over here is less than equal to 9. Now we have to find the value of function f g 1.5. So this basically means I place the value of g of 1.5 inside the function f. Now if I place 1.5 in g, I'll get 3 divided by 2 times 1.5 plus 1. So 3 divided by 3 plus 1, which is 4. So I basically want to find f of 3 by 4 or 0.75. Basically place 0.75 over here. So I get 9 minus 0.75 square. This will come out to be 135 by 16. So this is 135 by 16. Now we have to find g inverse. The function g of x is 3 divided by 2x plus 1. Now if I want to find g inverse x, I'll just replace the x with g inverse x and replace the g of x with x. So x is equal to 3 divided by 2 times g inverse x plus 1. Now I just have to make g inverse x the subject over here. I can move this up there, replace it with x. So 2 times g inverse x plus 1 is equal to 3 by x. I can move the plus 1 to the right. I'll get 2 times g inverse x equal to 3 by x minus 1. G inverse x will be equal to 3 by x minus 1 divided by 2. We can simplify this further. G inverse x is equal to 3 by 2x minus half. I can take 2x as the common denominator over here as well. I can write it down as 3 minus, if I have a common denominator of 2x, I just have to multiply x over here. So 3 minus x. We have to state the domain of this function over here as well. The domain of the inverse function is the range of g of x. So we have to remember the fact that the domain of g of x is the range of g inverse x, and the range of g of x is the domain of g inverse x. Prime and inverse are not the same. This is g prime. This is basically the derivative of g of x, while this is the inverse. You have to be careful with the sign over here. This is not equal to this. Now if I look over here at this function g of x, this is basically the function, it has an it's the function of 1 by x, but in the denominator we have 2x plus 1. So we have an asymptote when 2x plus 1 is equal to 0. So we have an asymptote when 2x is minus 1 or x is minus half. So vertical asymptote at x equals to minus half and a y asymptote at 0, or a horizontal asymptote at y equals to 0. This is the function. Now I won't even bother going into this bit over here, so the one in the bottom, since we are given the domain of x being greater than 0. So we'll also not consider this part. We start from here. So I need to find the value of this, and this will go to 0. That's the range of the previous function. So the range of g of x is bigger than 0, and I need to find this value over here. So I'll set x equals to 0. If I do that, I get 3 by 1, so this is 3, and this will be inclusive since this is greater than equal to. If this was only greater than 0, I will not have a greater than equal to sign over here as well. Since we have a greater than equal to sign here, there will be a greater than equal to less than equal to sign over here. So y is less than equal to 3. This is for this is the range for g of x. So this will be the domain of g inverse x. So the domain over here is 0 exclusive to 3 inclusive. So 3 is included over here. Now question 2 is about R form. We are given this question. We have cos x plus 2 sin x, and we have to express this in the form r cos x minus alpha. We'll just use the formula. So r is root over 1 square plus 2 square. So we have root 5 over here as r, and tan alpha will be equal to 2 divided by 1. So tan alpha is 2, alpha is tan inverse 2, which is we are instructed to give the value of alpha in radians to 3 decimal places, so we'll do that. I'll find tan inverse 2 in radians, and I'll give our answer to 3 dp. If I calculate this to 3 decimal places, I'll get 1.107 radians. So I can write this down as root 5 cos x minus 1.107 radians. Now we are given this function g of x, which is related to f of x, which is given over here. F of x is the R form we just found out, and we have to find the exact maximum value of g of x. Now we know that the maximum value for this function over here, f of x, will be root 5, since the maximum value of cos x minus 1.107 is root 5. Or this can at max be 1. So the maximum value for this is root 5. Since there is a minus over here, I'll consider the minimum value of f of x. The minimum value is minus 1. So the minimum value of this whole function is minus root 5. So the maximum value of g of x will occur when f of 2x is minimum. The 2x won't change the values that much. It won't affect the value since it's inside the angle. Having a 2 inside there won't change the maximum or minimum value of a function of cos. So cosine 2x minus 1.107 still has a minimum value of minus 1. It doesn't change just because we bring a 2 in front of the x. So the maximum value of g of x is 3 minus 7 times minus root 5. This will be 3 plus 7 root 5. Now we have to find the smallest positive value of x for which this occurs. So this occurs when root 5 times cos twice x minus 1.107 radian is equal to root 5. This is happening when this value is minus root 5. Therefore, cos twice x minus 1.107 radians will be minus 1. The basic acute angle will be cos inverse 1. Now we need the values to 2 decimal places, so I'll do the working with 3 decimal places, one more than the answer. Now cos inverse 1 is 0, and since this is negative, cos is negative in the second and third quadrant, these two over here. So twice x minus 1.107 is pi minus 0 or pi plus 0, the same value over here. If I calculate this, I get 2x equals to pi plus 1.107. X is pi plus 1.107 divided by 2. Now since this is not x, we have to change the limits as well. So we have to check with the first negative value as well if it's working or not. The first negative value, I'll rotate clockwise now for the negative values. So the first negative value occurs over here. For the negative axis, this is minus basic acute angle, this is minus pi minus, theta minus, minus pi minus theta, this is minus pi plus theta, and this is minus 2 pi minus theta, or the basic angle. Theta or the basic acute angle, they're the same thing over here. Now I'll check for this value over here. So minus pi minus 0. So I'll check if 2x minus 1.107 equals to minus pi gives us a positive value of x. If I try that, I'll get minus pi plus 1.107 divided by 2, with minus 1.017, which is a negative value. So we don't have to consider this over here. This will be our answer. We want this to 2 decimal places. If we do that, we get a value of 2.12 radians. Now for the next question. In question 3, we are given a graph of log base 10 of y against x. We have to find the equation of this line. We know 2 points on it. So we can find the equation of the line from here. We know the gradient over here will be y2 minus y1 divided by x2 minus x1. We can consider this point as x2 y2 and this point as x1 y1. So the gradient comes out to be 1.5 minus 0 and divided by 0 minus 4.8. So the gradient over here is 1.5 by 4.8, which is 5 by 16. Now we can find the equation of the line. We have y minus y1 equals to mx minus x1. We'll use this formula. Here instead of y, I'll have log base 10 of y. That's in the y-axis now. I'll consider this point over here. y1 is 0, the gradient is 5 by 16, and I have x minus 4.8, so this becomes positive 4.8. So log base 10 of y is equal to 5 by 16 x plus 3 by 2. This is the equation of the line L. Now for part B, we have to express y in this form over here. So we have to make y the subject now. In this case, we have log base 10y as the subject. In this case, we need y as the subject. So this is part A. Now we'll do part B. Now I can break this log down. So I'll use this law over here for logarithm. So log base B, log A base B being equal to C is basically the same as saying that B to the power C is equal to A. So in this case, we have log base 10 of y, which is equal to C. So the value B is 10. So 10 to the power 5 by 16 x plus 3 by 2 will be equal to y. Now if I break down the addition over here, I'll have 10 to the power 5 by 16 x multiplied by 10 to the power 3 by 2. We are using the law of indices over here. We are using the fact that 10 to the power a plus b is equal to 10 to the power a times 10 to the power b. Now if I use that, we can calculate 10 to the power 3 by 2, which is 31.6227. I want the value to 3 significant figures, so I'll have 31.6. And now I can write this term on the left as 10 to the power 5 by 16 to the power x. Now I can calculate 10 to the power 5 by 16 as well. To 3 significant figure, it comes out to be 2.05. So this is 31.6 multiplied by 2.05 to the power x. This is equal to y. Or we can just write it flipped now. So y is equal to this. Now moving to question 4, we have this function over here that we have to write down in this form. On the top, the highest power of x is 4, while on the bottom it will be 2. So I'll expand x plus 3 square at first. X plus 3 square when expanded comes out to be x square plus 2 times x times 3 plus 3 square. This basically means this is x square plus 6x plus 9. Now we'll use long division over here. So I'll divide f of x with the top of f of x, which is 2x to the power 4. So this function over here, 2x to the power 4 plus 15x cubed plus 35x squared plus 21x minus 4. And I'll divide this with x squared plus 6x plus 9. The first term we'll get on the top is 2x squared. So this will be 2x to the power 4 plus 6x cubed plus 12x cubed plus 18x squared. Now we'll subtract this over here. This will become minus, this will become minus, this will become minus. And if I calculate this, This will come out to be 3x cube plus 17x square plus 21x. I'm writing 3 terms down together since there are 3 terms on the divisor. Now I'll multiply 3x. I'll get 3x cube plus 18x square plus 27x. We'll subtract this thing as well. We'll get minus x square minus 6x minus 4. So we get minus 1 over here, and I'll have minus x square minus 6x minus 9. We'll subtract this as well. So this will become positive, this will become positive, this will become positive, since two negatives make a positive. So this 2 will cancel out. However, we'll not have a cancellation here. We have minus 4 plus 9, which is 5. Now we can write down f of x as 2x square plus 3x minus 1 from the quotient, and from the remainder we'll have 5 divided by the divisor. So 5 divided by x square plus 6x plus 9. This can also be written as x plus 3 whole squared, so I'll just do that, that's more convenient. So we'll add that at the end. Now this is in the same form as they asked us to. The value of a is 2, the value of b is 3, the value of c is minus 1, the value of d is 5. Now for question B, we have to find the integration of f of x. We'll use this form over here. So f of x can be written as 2x square plus 3x minus 1 plus 5 times x plus 3 to the power minus 2. If I move the denominator to the top, the power's sign will flip. Now if I integrate this thing, I'll get 2 by 3x cube plus 3 by 2x squared minus x plus 5 divided by minus 1 multiplied by x plus 3 to the power minus 1 plus c. So if I simplify this, we have 2 by 3x cube plus 3 by 2x square minus x minus 5 divided by x plus 3. Since we have the power of minus 1, this to the power 1 plus the constant c. And that's it for this question. Moving on to question 5, we have a question about proof. In the first part, we have to prove that cot square x minus tan square x is 4 cot 2x times cosec 2x. Now if we begin with the left hand side over here, I'll just write them in cos and sine. If we don't find anything that we can do right now, we'll start by converting them into sine and cos. So cot square is 1 by tan square or cos square by sine square. So we have cos square x by sine square x. Before that, I'll write down that we are beginning from the left hand side, and then we subtract sine square by cos square from it. So we have this expression over here. From here we can have a common denominator of sine square x cos square x. And on the top we'll have cos to the power 4x minus sine to the power 4x. Now we can use the formula that a square minus b square can be written as a plus b times a minus b in this case. So from this we can write down the numerator of this expression as cos square x plus sine square x multiplied by cos square x minus sine square x, and the whole thing is divided by sine square x cos square x. Now the denominator can also be written down as, so this expression over here can be written down as sine x times cos x whole square. Now inside the bracket we can calculate that we can use the identity that the double angle formula for sine. So basically use the formula, the fact that sine twice x is equal to 2 sine x cos x. We don't have a 2 in front of it, so we'll divide both sides with 2. I'll get a half. So this thing over here is the same as half sine twice x squared. And now we'll just we'll also calculate the numerator. If I do that, I have cos square plus sine square x over here. This will be 1. We have 1 times cos square x minus sine square x. So 1 multiplied by cos square x minus sine square x divided by half sine twice x whole squared. Now we can use the double angle formula for cos for converting this. We know that cos twice x is cos square x minus sine square x. From there we can write down sine square x as we don't have to do anything over here. We can just replace this blue thing with cos twice x. So we'll have cos twice x divided by half sine twice x whole square. Now we'll move to question 4b. We have to find the values of theta for which this expression holds. Now if we look over here, this thing over here and the term on the left are the same, just instead of x we have theta, and this is equal to 2 tan square theta. So 2 tan square theta will be equal to cot square theta minus tan square theta. Now I can move the tan square to the left. We'll have 3 tan square theta is equal to 1 by tan square theta. We basically get 3 tan to the power 4 theta is 1. 10 to the power 4 theta is 1/3. The value of tan theta will be plus or minus the 4th root of 1/3. Tan theta will be equal to plus or minus 0.7598. From here I can find the values of tan theta. The basic acute angle over here will be tan inverse 0.7598, and since the value is wanted to 2 decimal places, I'll find it to 3 decimal places before. So I'll use one more than the answer for our working. This comes out to be 0.650. Now since we have a plus or minus, we'll consider all 4 quadrants. So all 4 quadrants will be considered. The range over here is from minus pi by 2 to pi by 2. So this quadrant and this quadrant over here in negative. For the positive one, we have theta equals to 0.65, and for the negative one, we have minus 0.65. So these are our answers. Now moving to question 6. We are given this curve with a modulus over here. We have to first find the coordinates of point P, Q, R, and S. So point P is at the y axis. On the y axis, x is equal to 0. So we'll place x equals to 0 in this equation. We get 3 times 0 minus 5a minus 2a. Now in the modulus sign, we don't care about the minus, we only want the magnitude. So we have 5a minus 2a, which is equal to 3a. So the point P is 0, 3a. And now for points Q and R, so these 2 points, the value of y is 0. So this is for 1. For 2, we have y equals to 0, and we have to find both values of x for which this happens. If we have a plus over here, then we'll have 0 equals to 3x minus 5a minus 2a, or we'll get 0 equals to 3x minus 7a, 3x equals to 7a, and x will be equal to 7 by 3. Or we can have a minus over here. If that happens, we get 0 equals to minus 3x minus 5a minus twice a. If we solve this, we'll get minus 3x plus 5a minus 2. Move the 3x to the left, and on the right we are left with 3a. So x will be equal to 3a by 3, and x will be equal to a. Now if we look at this graph, q is on the left, and we also know that a is a positive constant. So q will be a comma 0. Since it's on the left, its value of a should be less than that for r, and r is at 7 by 3a comma 0. So q is a comma 0, and r is 7 by 3a comma 0. Finally, we have to find point S, or the turning point over here. Now for any turning point, the whole modulus, only the modulus part, must be equal to 0. So for part 3, we have to solve 3x minus 5a equal to 0. Here we'll have 3x equals to 5a, x will be equal to 5 by 3a. Now this is the x coordinate. We have to find the y coordinate as well. The y coordinate for this will be 0 minus twice a, so y is minus twice a. So we have point S, which is 5 by 3a comma minus twice a. Now for part B, we have to solve this equation over here and find the values of x in terms of a, for which this equation holds. Before we go into this, it's better if we sketch a graph of x minus twice a inside a modulus. We have x minus twice a, so the turning point is at 2a comma 0. This point is 5 by 3, 2 is to the right of it, So the turning point is over here, and the gradient for this part of the equation, so x minus twice a is 1, so it's less steep. The gradient over here is 3, this gradient over here will be 1. So these are the two intersections. At the intersections, the positive part of this equation and the positive part of this equation matches, and the negative matches with the negative. So when we have a plus over here, there is a plus over there. When we have a minus over here, we have a minus over here. So 3x minus 5a minus twice a will be equal to x minus twice a. We just have to solve this. Move the x to the left, I get 2x, and by moving the a's to the right, we get minus 2a plus 5a plus 2a. We are left with 2x equals to 5a, or x equals to 5 by 2a. And the other value of x would be when both of them are negative, so minus 3x plus 5a minus twice a equals to minus x plus twice a. Now I'll move all the a's to the left and the x to the right to keep x positive, so I get 5a minus twice a equals to minus x plus 3x. On the left we have 5 minus 4, so 1a, and on the right we have twice x, so x will be equal to a by 2. So these are the values of x for which this equation holds. Now we'll move to the next question. We have this equation over here of x. We have to differentiate this and show that the derivative comes out in this form over here. Now one thing we have to be careful about is to look at the fact that this is x, not y. We are given the equation in terms of x, while we have to show dy by dx. So at first we have to differentiate like this. We have to find dx by dy, differentiate this thing with respect to y, since this is a function of y. So if I do that, dx by dy is the derivative of 3 tan y minus pi by 6. If we differentiate a function of tan, we'll get sec square, so we are left with 3 sec square y minus pi by 6 over here. So this is dx by dy. Now if I want to find dy by dx, I'll just find the reciprocal of this. So 1 divided by dx by dy is equal to 1 divided by 3 sec square y minus pi by 6. 1 by dx by dy is the same as dy by dx. This will be equal to now I have to work with this. Now if I look over here, dy by dx does not contain y over here. On the right we don't have an y, so we have to use this function over here to replace the y we have here into x. Now we know that sec square x is equal to 1 plus tan square x, so I can just place it over here. So we have 1 by 3 1 plus tan square y minus pi by 6 . So dy by dx is equal to, now over here we can replace this with x square divided by 3. Sorry, this will be whole squared. This is because tan square y minus pi by 6 is the same as tan y minus pi by 6 squared. Now tan 3 tan y minus pi by 6 is x. So x divided by 3 is tan y minus pi by 6. This is the same thing over here. So this is x divided by 3 whole squared. So I can write this down as 1 divided by 3 times 1 plus x square by x by 3 whole square, my bad, x by 3 whole square. So we have 1 divided by 3 plus x by 3 whole square is basically x square by 9. So this will be x 3 times 9, we'll be left with x square by 3 over here. We can multiply the top and the bottom with 3. Since the coefficient in front of x square is 1, we have to make the coefficient 1. So we have to multiply the top and bottom with 3. I'm left with 3 divided by x square plus 3 times 3 is 9. So the value of b is 9, the value of a is 3. Now we are given that point P with y coordinate pi by 3 is on the curve C, and that the tangent to the curve at P crosses the x-axis at Q. We have to find the exact coordinate of x. When y is pi by 3, we can put it over here and find the value of x. This will be 3 tan pi by 3 minus pi by 6. So 3 tan pi by 6. This is equal to root 3. So the point P is root 3 comma pi by 3. Now we have to find the equation of the tangent, so we need its gradient. Its gradient will be found by placing the value of x equals to root 3 over in this equation. So the gradient of the tangent is 3 divided by root 3 squared, so 3 plus 9. We are left with 1 by 4. So the gradient of the tangent is 1 by 4. Now the equation will be y minus y1, in this case pi by 3, equals to the gradient, which is 1 by 4, x minus x1, the x coordinate is root 3. So the equation of the tangent is x by 4 minus root 3 by 4 plus pi by 3. And we have to find the exact coordinate when the tangent crosses the x-axis. At x-axis y equals to 0. So we'll place 0 equals to x by 4 minus 3 root 3 by 4 plus pi by 3. We'll move the other values except x to the left. We'll be left with root 3 by 4 minus pi by 3 equals to x by 4. We can multiply the 4 over on the left. We'll be left with root 3 minus 4 pi by 3 equals to x. So this is the value of x. Now moving on to question 8. We have to integrate this function over here. Now if we break down the square, we'll have 4 cos square x. So basically we have 2 cos x whole square minus 2 times 2 cos x times sin x plus sin square x dx. So the integral is of 4 cos square x minus 4 sin x cos x plus sin square x. Now we'll use the formula for cos square and sin square. Cos square x is half plus cos twice x by 2, while sin square x is half minus cos twice x by 2. So we'll place that value over here and the other one over here. And for the case of 4 sin x cos x, we'll have to use the fact that 2 sin x cos x is equal to sin twice x. So in this case I'll multiply both sides with 2. I'll be left with 4 sin x cos x equal to 2 sin twice x. I'll place those values over here. So I have 4 half plus cos twice x by 2 minus 2 sin twice x plus half minus cos twice x by 2 dx. Now we have stuff that we can integrate. Before that I'll just multiply the 4, so I'll be left with 2 plus 2 cos twice x minus 2 sin twice x plus half minus cos twice x divided by 2 dx. We can write the 2 and the plus half together as 5 by 2 . Now if I integrate this, I'll be left with 5 by 2x plus 2 divided by 2 sin twice x minus 2 divided by 2 cos, sorry, this will become plus cos twice x. We could have got these values together as well, these two. So 2 minus half, we'll do that. Since both of these terms are of cos twice x, we can write that down as 2 minus half or 3 by 2 cos twice x. So we'll have 3 by 2 divided by 2 sin twice x plus 2 divided by 2 cos twice x. We didn't have a limit over here, so plus c. We'll be left with 5 by 2x plus 3 by 4 sin twice x plus cos twice x plus c. Now moving to question 9, the penultimate question over here. We are given this curve with this equation over here. We have to find dy by dx for the first part. We have to differentiate this function over here. For this we have to use the chain rule. So if I want to find dy by dx, this will be u. The formula for this will be du by dx. Dy by dx is equals to dy by du multiplied by du by dx. Y can be written as u to the power half, so dy by du is half times u to the power minus half. I'll write that at first. So dy by dx is half times u to the power minus half. U over here is the whole thing, so I'll just write it down again. So this is u, and we have it to the power of minus half. And outside we have to write down du by dx. U over here is 3 plus 4e to the power x squared. If I differentiate this with respect to x, the 3 will become 0 and the 4e to the power x squared will become 8x times e to the power x squared. Basically I'll have 4 multiplied by the derivative of x squared, so this is twice x, and e to the power x squared, so 8x e to the power x squared. We can simplify this by multiplying half and 8. We'll be left with 4x e to the power x squared multiplied by 3 plus 4e to the power x squared to the power minus half. Now for part B, we are told that for the point P, the tangent to the curve passes through the origin. So the x coordinate of this value is alpha, and the tangent to the curve at alpha passes through the origin. And we have to use that fact to show that alpha is a solution of this equation. We know that this is the value of alpha, and we know dy by dx as well. We know y and dy by dx. Dy by dx is this expression over here. We can put the value alpha over there and find the value of y and dy by dx. The value of dy by dx is the gradient of the tangent. Now we can use the fact that y minus y1 equals to gradient times x minus x1. This is the equation of the tangent. We can use this. So y minus root over 3 plus 4 e to the power alpha square, instead of x we'll just place alpha, is equal to m. So we have 4 alpha times e to the power alpha squared times 3 plus, I'll do it down in this. So this is part B. The gradient will be 3 plus 4 e to the power alpha squared to the power minus half. And now we'll multiply x minus x1. x1 is alpha. Now we just have to solve this equation over here into this. We have to use the fact that when x is equal to 0, y will be equal to 0 for this graph. So I'll just place 0 over here. This is minus 3 plus 4 e to the power alpha square, and on the right we have 4 alpha e to the power alpha square multiplied by 3 plus 4 e to the power alpha square to the power minus half times 0 minus alpha. Now we can multiply or divide both sides with root over 3 plus 4 e to the power alpha square, multiply it on both sides. This is basically 3 plus 4 e alpha to the power half. So you can multiply both of them together. On the left hand side I'll be left with 3 plus 4 e to the power alpha square. On the right, this thing will cancel with this. I'll be left with 4 alpha e to the power alpha squared So this, since there's a minus over here, this will be minus 3 minus 4, and we have this expression multiplied by minus alpha, so minus 4 alpha square e to the power alpha squared. Now we have to show this expression. Here 4x square e to the power x square is positive, so I'll move this to the left. I'll be left with 4 alpha square e to the power alpha square minus 4 e to the power alpha square minus 3 is equal to 0. Now if I compare this with the equation given over here, it's the same equation, just in place of x we have alpha. In place of x we have alpha. In place of x we have alpha in all cases. Everything else is the same. So alpha is a solution to this equation. We can prove this. Now we go to a numeric method. We have to show that alpha lies between 1 and 2. To do that, we'll just write down f of x is 4 x square e to the power x square minus 4 e to the power x square minus 3. Now if x is 1, we'll just put 1 over here, so 4 times 1 square e to the power 1 square minus 4 times e to the power 1 square minus 3. This value comes out to, this will come out to be minus 3. And f of 2, this is 4 times 2 square e to the power 2 square minus 4 times e to the power 2 square minus 3. This will come out to be, this comes out to be positive 652.177. We just need the sign over here, so I can take it to 3SF only. This is 652. Now this, I use this since if the curve has a root over here, so if this equation has to be 0, on one side it must be negative. So if I consider this as the y-axis and this as the x-axis, over here this is 1, over here the value is negative, and this value is 2, over here the value is positive. So if it goes from negative to positive, or it goes from positive to negative, so if this was negative and this is positive, like in this case, or if this was 652 and this was minus 3, so something like this, it doesn't need to be a straight line, it can be a curve like this. In this case, this is positive on the left and negative over here. So if the value changes from negative to positive, it must cross the x-axis if it's continuous. So in between 1 and 2, it must cross the x-axis. So the value of alpha is somewhere in between 1 and 2. So we can say that since the signs are different, so one is negative and one is positive, we can be sure that alpha lies between 1 and 2. We also have to state that the curve is continuous in this interval. An example for the requirement of this is 1 by x. Now this is the graph for 1 by x. If I look over here, this is a negative value and this value over here is positive. So if I take 1 and minus 1, for 1 we'll get a positive value, for minus 1 we'll get a negative value. But in between 1 and minus 1, the curve does not cross the x-axis. The issue is over here, the curve does not continue. The curve goes here and then there's a break and it continues from here. So it's not continuous in this intervals. So we have to also mention the fact that it's continuous between this interval. So there is a change in sign. and the function is continuous. So this is the reason that we can say alpha is between 1 and 2. Now we have to show that the equation in part B can be written in this form. So this function over here, in this case we have root over 4 plus 3 to the power minus x square on the right, a half over here. We want to make x the subject. So this is the equation we had. We'll have x. So I can move this to the right. I have 4x square e to the power x square equals to 4 e to the power x square plus 3. Now I can multiply e to the power, so I can send e to the power x square to the right. I'll have x square over here, and I'll divide this side with 4 times e to the power x square. So x square becomes 4 e to the power x square divided by 4 e to the power x square is 1, and the second term is 3 by 4 e to the power x square on the bottom, or we can write this down as 3 by 4 e to the power minus x squared. Now if I look in this case, I have a half common on the outside, so I can take 1 by 4 common over here. I'll have 4 plus 3 e to the power minus x square. I take 1 by 4 out as common because if I take the square root of the right side, I'll be left with half from this part. So on the next line, I square root the right, I'll be left with half times 4 plus 3 to the power minus x squared. Now for part E, we have to use this function as the iterative formula. So I'll just convert this function into the iterative formula and use x1 equals to 1 as the first approximation, and calculate the value of x3 and alpha. So the iterative formula, I'll just use this. x1 is 1. I'll place that into the equation for this to find x2. This is half times 4 plus 3 e to the power minus 1 squared to the power half. This is minus 1 squared. So this and this are different. This is minus 1, this is plus 1. So the square is on 1 only, not on the minus sign. Have to be careful on that. There's a neat calculator trick for questions like this. So for questions like this, I'll just write down the equation that we have in our calculator like this. The equation was half times 4 plus 3 e to the power minus x. So from here I'll just press alpha and this button. X is over here, and we have a square on the x, and we have a power of half over the bracket, and then I'll press the calc button and place this value. So 1 at first. If I calculate this, I get a value of 1.1295. They want the values to 4 decimal places, so this will be 1.1296. So x2 is 1.1296. Now for the value of x3, I'll just press calc button again and then press the answer button. This will basically use this value over here as the value of x for the next question. Press equals to, now I'll get a value of 1.0997. This is the value of x3. This is part 1. Now for part 2, I have to find alpha. I'll find alpha when two consecutive values are the same up to 4 decimal places. So I'll have to continue with this. x4 will be calc answer. This is 1.1063. We do it again. x5 is 1.1048. We calculate this again. This comes out to be 1.1051. I'll do it again. Calcans. The next value, x7, is 1.1051. So we have had two consecutive values that are the same. So the value of alpha must be 1.1051. That's it for this question. I will move on to the last question now. So we have a population of fruit flies being studied. The number of fruit flies f after t days is modeled using this function over here. From that, for part A, we have to find the number of fruit flies when we started the experiment. So the value of f when t is equal to 0, I'll be left with 350 e to the power 0 divided by 9 plus e to the power 0. Now e to the power 0 is 1. So f is equal to 350 divided by 9 plus 1. So the initial population was 350 by 10 or 35. We can also write this down as f naught. So the initial population is 35. This is 35. Now we are told that 200 fruit flies are in the population 15 days after the study is started. We'll place the value of t equals to 15. For that, f must be 200. We'll place those values in the equation. So I'll have 200 equals to 350 times e to the power 15k divided by 9 plus e to the power 15k. We can cross multiply this. I'll be left with 200 into 9, which is 1800, plus 200 e to the power 15k is equals to 350 times e to the power 15k. I'll move this term to the right. I'll have 1800 equals to 350 minus 200 e to the power 15k. So 1800 is equal to 150 e to the power 15k. Now I can divide both sides with 150. I'll be left with, on the left I'll be left with 12, on the right I'll be left with e to the power 15k. Now I just to find the value of k, I'll take the natural logarithm of both sides. So ln 12 is equal to ln e to the power 15k. Now for ln e to the power anything, this is equal to anything. So if I had 3k cube over here, this is 3k cube, because ln e is 1. So I can move the power down here and ln e will be 1. So ln 12 is equal to 15k. So 15 15k is ln 12, and therefore k is 1 by 15 ln 12. This is what we had to show over here. Now we are given that when small t is equal to capital T, the number of fruit fly is increasing at a rate of 10 per day. So for this case, I have to find df by dt. Now I want to find df by dt, so I'll have to use the quotient rule over here. So I'll consider this to be u, and the denominator will be v. So u is 350 e to the power kt. I need to find du by dt. This will be, I know the value of k as well, it's 1/15th ln 12. I'll not directly place it as it will be harder to calculate. It will be harder to write down, not calculate. So it will be harder to write down this whole expression every single time, so I'll just keep it k. If I differentiate this with respect to t, I'll be left with 350k e to the power kt. And on the other side, about v is 9 plus e to the power kt. If I differentiate this with respect to t, I'll be left with k e to the power kt. Now df by dt will be dv by dt times, it will be v times du by dt minus u times dv by dt and divided by v square. So we are using the quotient rule over here. V is 9 plus e to the power kt. Du by dt is 350 times e to the power kt. Sorry, 350k. We have 350k e to the power kt minus u, which is 350 e to the power kt times dv by dt, which is k e to the power kt, and it's divided by 9 plus e to the power kt whole squared. So we want the rate of increase to be 10. So we want this expression to be equal to 10. And now we'll solve it for this case. Now for the numerator, we have 9 times 350k, which is 3150. We have 3150k e to the power kt plus 350 e to the power 350 e to the power, we have 350k e to the power 2 kt. We are basically using the law of indices, which says that a to the power m times a to the power n is a to the power m plus n. And then we have minus 350k e to the power 2 kt. This cancels out with this, and for the denominator we are left with 9 square plus 2 times 9 times e to the power kt plus e to the power kt whole squared. This is equal to 10. So on the top we have 3150k e to the power kt, and for the denominator we have 81 plus 18 e to the power kt plus e to the power 2 kt. We are using the fact that a to the power m whole to the power n is the same as a to the power mn. This is equal to 10. We can cross multiply now. We have 3150k e to the power kt equals to 810 plus 180 e to the power kt plus 10 e to the power kt 2kt. We could divide both sides with 10, so we'll be left with 315 k e to the power kt equals to 81 plus 18 e to the power kt plus e to the power kt squared. Now we can consider e to the power kt as a new variable. I'll consider this variable p, for example. You can use other letters as well which have not been used in this question. So we couldn't use this as t or k. You'll have to bring something new. So this is equal to e to the power kt. Now I'll have 315p equals this 315 kp equals to 81 plus 18p plus p square. We can consider this as a quadratic. I'll be left with p square plus 18p minus 315 kp. So I'll just move it to the right, plus 81 equal to 0. I can take p common over here, write it down as 18 minus 315k times p plus 81 equals to 0. Now I can use the quadratic formula. So p will be equal to minus b plus minus root over b square minus 4ac by twice a. This is a, this is b, and this is c. So p will be equal to 18 minus, so minus this, so 315k minus 18 plus or minus root over 18 minus 315k whole square minus 4 times 1 times 81 divided by 2 times 1. So p is now I can just we don't have to continue further like this. I can take p back to e to the power kt. Now the t will be the capital T, since the calculations we are doing are for when it's 10. So this is capital T. So you can convert all the t's over here to capital T, since we are already placed, we have placed the place this to be equal to 10. This is equal to this expression over here. We can break it down further, write it more simply. So 18 square minus 2 times 18 times, you could do without that as well, so just keep as it was. So 18 minus 315 times k whole square minus 4 into 81, which is minus 324 divided by 2. Now the value of t, or here the value of kt, will be found by taking the natural log on both sides. So ln e to the power kt is equal to ln this expression over here. So this is the equation we have. Ln e to the power kt is the same as k times t. So to find t, I'll divide the right side with k. So ln times the expression over here divided by k is the value of t. Now we'll take one value with plus over here and the other value with minus. So one value of t is And now in place of k, I'll place 1 by 15 ln 12. This is one value, so plus this, and I'll place the value of k equals to 1 by 15 ln 12 in this case, and find the value of t to one decimal place. This is 20.848, sorry, 20.849, or to one decimal place this will be 20.8. And the other value will be when we have a minus over here instead of a plus. So the first is for minus, the second will be for, so the first one is this value over here is when we have a plus over here, and the next value is when we have a minus. I'll once again place the value of k to be 1 by 15 ln 12 over here, place the values and put it in the calculator. If I do so, I'll get a value of 5.678 or 5.7 to one decimal place. These are the two values of t, and that's it for this paper.